Hello. So today I'm going to give you a quick introduction to the circuit simulation software Tinkercad and show you how to create some basic circuits step by step. So let's dive into it. Okay, so when we create a new project, we have our dashboard like this. So this is our workspace. Here we can give a title. So let's give a title Basics of Tinkercad. Then at the right hand side, we have the component section. So we have a lot of categories in the components. First, we can see we have resistors, LED, push button, potentiometer, all the basic components that we can use. If we select all, we can see all the components here. So we have all the components from diode, zener diode, inductor. In the input devices, we have push button, potentiometer, the photoresistor sensor, ambient sensor, force sensors, a lot of sensors. Output, we have all the LEDs, the NeoPixel rings, the DC motors, piezo's, IR remote, and LCD display. On the power side, we have three types of batteries: the 9-volt battery, 1.5-volt battery, coin cell. Then we have some ancient potato battery, lemon battery. We have our breadboards and some microcontrollers. In Tinkercad, there are just a microbit controller and an Arduino controller. In instruments, we have multimeter, power supply, function generator, oscilloscopes, and we have almost all types of ICs. We have 555 timer, an operational amplifier, a dual comparator, optocoupler, transistors we have, then some basic connectors like a USB standard A connector, and all the logic gates, the NAND, NOR, AND, OR, XOR. So let's start with a basic circuit. Let's start with a battery and an LED. Let's try to light up an LED using a battery. So in Tinkercad, to rotate any component, we can just press R to rotate it clockwise and Shift plus R to rotate it anti-clockwise. So let's place the components. Now I'll connect the negative terminal of the battery to the cathode. So you can just click on anywhere on the screen to create a bend. And then let's connect the positive of the battery to the anode. So I'll color code them. So I'll select the wire. Here is the color option and I'll change the color. Great. Now let's simulate it. We see our LED is burst and we are having an error showing that current through the LED is 915 milliamp, which is absolutely maximum than its operating current. So to tackle this issue, we will add a resistor in series with the circuit. So I'll take a resistor from the components, we'll place it in series. And let's give the value of the resistor as 350 ohms. If we calculate it using the Ohm's law, we get around 350 ohms. So when we simulate it, yes, now we have the LED glowing without any errors. Okay, so let's make it more interesting by adding a potentiometer. So we'll add the potentiometer in series with the circuit. So I'll disconnect this connection. So in potentiometers, we have three pins. So terminal 1, a wiper pin, and a terminal 2. So the wiper pin moves across the terminal 1 and terminal 2, connecting it either to terminal 1 or terminal 2, creating an internal resistance. So we'll connect the one of the pin from the resistor to the wiper and the other terminal pin to the anode. We change the value of resistor a bit lower so we can see the change in the brightness more accurately. And let's give the potentiometer a value of 1 kilo ohm. Now when we start simulation, so now we can see that by turning the potentiometer, we are able to see the brightness of the LED dimming and increasing as we are moving the potentiometer. Okay, so now to visualize it more better, let's add an current meter in series. So I'll go to the components, I'll search for multimeter. I'll take it and I'll disconnect this connection. So we will connect the negative of the battery to the negative terminal of the multimeter, and the positive of the multimeter to the cathode. So I'll again change the color of the wires, and I'll right click on this, and I'll change it to amperage. Now when I start the simulation, now you can see that as I am increasing the resistance, the current is decreasing, and as decreasing the resistance, the current is increasing. In Tinkercad, we also have an option of schematic view. So if we go on the top right corner, we are able to see a schematic view option. So if we click on it, we are able to see a schematic. This is automatic generated schematic which we can use further. We also have a component section where we are having a list of components that we have used in our circuit. So this will be a very useful tool for creating PCBs or any of the projects you are making. Great. So now let's move on to a new component. I'll delete all these components. So let's talk about breadboard. So I'll go to the components. I'll search for a breadboard. This is our breadboard. The middle partition of the breadboard is the notch for the IC. We typically have 5 clips, that is beneath 5 and the above 5, which are electrically connected. The 5 columns on the bottom of the notch A, B, C, D, E are electrically connected, and the above F, G, H, I, J are electrically connected. So let's try to light up multiple LEDs. We'll connect the LEDs parallelly like this. Again, I'll take a battery and place it here. So I'll connect the positive of the battery to the positive rail on the breadboard and the negative of the battery to the negative rail. I'll again change the color for the positive rail. Now I'll connect the cathode of the LEDs to the negative rail. I'll again change the color, and I'll add a resistor to limit the current. So I'll add the resistor from the anode of the LEDs to the positive rail. Here again I will give the value as 350 ohms, and I'll start the simulation. Now again, if we go to a schematic view, this is our schematic. So that was a quick and simple introduction to using Tinkercad for basic circuit simulation. We started with the essentials, learning the interface, connecting a battery and an LED, and then gradually added components like resistors, potentiometers, and even a multimeter. If you found this video helpful, don't forget to like, share, and subscribe for more electronics and circuit building content. Thank you.